Okay guys, here we go. We're going to start with problem number 5. Switch software should be a lot nicer. I'm going to go with problem number 5. I thought I did it somewhere else, but I'm going to do it again here just in case. We're talking about a manufacturer revenue generating X units of certain commodity. You're looking for the maximum, so you should automatically realize that this function right here is going to be a maximum because we have vertex. So let's grab this pen and see what we got going on here. There we go. So that tells me Rx is equal to 80x minus 0.4x squared. I need to rewrite this because I like the quadratic part first. So that should be negative 0.4x squared plus 80x. I'm going to factor out a negative 0.4. So that tells me when I factor out that negative 0.84, I'm left with an x squared. This becomes negative. Anytime you factor something out, it's just like you must divide that piece by that 0.4, which gives us 200x. Go ahead and put the plus the blank spot because I'm anticipating my complete the square. I know that's a plus a blank spot, so I must take it away. I know this becomes minus 0.4x. Half of 200 is 100. We're going to square it. 100 squared is 10,000. 4 zeros. Check with the gatekeeper. That's negative 4,000. Now if you clean all that up, I'm going to bring it up here. That should be negative 4.4 x minus 100 squared plus 4,000 because the negative times a negative. Now you know your vertex now is 100 because it's in vertex form. 100 and 4,000. So that tells you that you want to sell 100 units, right? And the maximum revenue is going to be what? 4,000. List all possible zeros. That's 8 over 12. P's and Q's 1, 2, 3, 1, 2, 4, and 8. This is 1, 2, 3, 4, 6, and 8. Everybody got to dance. So the 1's going to dance with who first? Everybody. 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, 1 over 8. Now the 2's got to dance. 2 over 1, 2 over 2, 2 over 3, 2 over 4, 2 over 6, 2 over 8. Continue to do that. Reduce, put plus and minuses, see what you got. Next question. Determine how many positive real zeros. Anytime you see determine how many positive zeros, we know we have P of x equals x to the 5th plus 4x cubed minus x squared plus 6x. Negative says you substitute P of minus x, which says you change the sign on the negative exponents. Minus x squared minus 6x. Count your sign changes. 1, 2 sign changes. Here we're going to have 1, 2 sign changes. Descartes looks something like this. We know we have plus, minus, and we have complex and total. Highest degree is 5, right? So I know I can have 2, 2, so that means I gotta have 1 here. Can I subtract 2 from here? Yes. Gotta copy everybody else. That gives me a 3. I'm done with the pluses, so go back to the top row. Ask yourself, can I subtract 2 from here? I can, so that becomes 2, 0, 3, 5, right? Now you can ask yourself again if you want to, can I subtract 2? I've already done that. So now you look at it and you go, how many positive real zeros I'm going to have? I can either have 2 or 0. How many negative real zeros I'm going to have? I'm either going to have 2 or 0. That's Descartes. Find all zeros on number 8. That simply says what? Try to factor. We can't factor. I'm going to put this in full representation. I don't have a squared term, minus 2x plus 4. I know right off the bat I'm going to have let's try synthetic division. 1, 0, minus 2, dot, 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 4. I'm going to try negative 2 because I know 4 breaks down to 1, 2, and 4. 1, minus 2, bring down, multiply. 2 times 1 is minus 2, is positive 2. So that gives me a positive 2. That makes this a positive 2. 2 times 2 is 4. Okay, this is a negative 2, sorry. 2 times 2 is 4. Okay, let's erase this a little bit. Get rid of all that. That just looks like trash. That's better. What are we trying here? We said we were going to try a negative 2, right? I know negative 2 cubed right here is negative 8 plus 2 plus 4 plus 4 is going to work. But let's prove it because we're going to need it anyway. Minus 2, 4, 2, minus 4, 0. That leaves me with x squared minus 2x plus 2 equals 0. You know if I use the quadratic equation, that's going to be plus 2 plus or minus square root of minus 2 squared minus 4, 1, 2, which gives me 4 minus 8, which gives me a negative 4. Since that's a negative 4, that cannot be zeros underneath, that's going to cross the x-axis. So therefore, my only 0 is x equals negative 2. Alright, find all zeros. We're going to factor out an x. I'm going to be left with 4x squared plus 9. Set each piece equal to 0. We know we have 4x plus 9. 4x squared equals 0. I end up with x squared equals minus 9 over 4, square root. I'm left with x equals plus or minus 3 over 2i. Imaginary, the only 0 we have is x equals 0, multiplicity of 1. Cool. Find all zeros. Anytime you see 4 terms, you get excited. Try to factor out something in common. I'm going to pull out an x squared, x cubed. I have x squared plus 1 plus 8, x squared plus 1. Kill the twins. I have x cubed plus 8 times x squared plus 1. You got to go back and remember that. How do you factor the sum of 2 cubes? Well, that's simply a plus my b, which is 2, x squared minus, plus ax. My a is x, my b is 2, and then you square that last term, which will give me 4. Set that equals 0. This guy here does not give you 0, so your only 0 going to come from x equals what? Negative 2. Done. Alright, now we're cooking with grease. It says find all the intercepts. Before you do anything, you should try to factor. Top becomes x minus 1, bottom becomes x squared, x minus 3. You know you're going to have a 0 at x equals 0, x equals 3. Degree on top is 2, degree on bottom. So that should be y equals 0. Horizontal asymptote should be does not exist. Some of you guys left it blank, so I counted it right, giving you the benefit of the doubt. Number 12, same thing. Trying to factor first. I see x squared plus 5, so I see x plus 4, x plus 1. Nothing factors, so I have an x minus 3 here, so that should be x equals 3. Horizontal should be does not exist because the degree on top is bigger by 1. I'm going to have a horizontal asymptote, so you got to go to old school division. Let's jump up here and do it. I have x squared plus 5x plus 4 divided by x minus 3. X minus 3, that gives me an x. That gives me x squared minus 3x. Change the signs. Just in case somebody don't see it, let's go over here and change that color to minus plus. That cancel. That gives me 8x plus 4. Trying to get an 8x, I need a plus 8. Right there, doesn't matter what the remainder is going to be, because that tells me my horizontal asymptote is y equals x plus 8. Let's go back to black. I know I have 5/8 x squared. My degree on top is the same, so I have to take 5/8 divided by 2/3. Don't like to divide, so I'm going to flip and multiply by the reciprocal. 15 over 16 becomes my horizontal asymptote. Y equals 15 over 16. Oblique does not exist. Can we factor that bottom? That gives me 2/3 x squared minus 3, set equal to 0. So I'm going to multiply by 3, give me 2x squared, give everybody a 3, minus 9 equals 0, x squared minus 9 equals 0, equals 9, sorry. Divide by 2, x squared equals 9 over 2, take the square root, take the square root. What's square root of the whole thing? Should give me 3 over the square root of 2. You know we like to do what? Take out, bring up. That's how you rationalize the denominator. Right? Cool. So that should be your what? Vertical asymptotes. How many of them do you have? 2, because you took a square root. Right? So my vertical asymptote should be x equals 3 square root of 2 over 2, or x equals minus 3 square root of 2 over 2. Next one says find a polynomial with integral coefficients that satisfy the given condition. You remember, we're going to call it Q. X equals, has a degree 3, 0 is a 3, x minus 3, degree is 3, x minus 3. He's got to have an x minus 1 minus I, and for every conjugate he has a cousin, very complex, so that becomes 1 plus I, right? Then you got to clean this up. Now there's a very slick rule here, but I'm gonna go ahead and clean it this way. Notice this becomes x minus 1 plus I. This becomes x minus 1 minus I, right? Now you got to dance all of that stuff out, see what you get. That turns out to be, I can't remember. So hold that thought for a second. I'm going to hit pause. After multiplying that out, I get x cubed minus 5x squared plus 8x minus 6. Dance, 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 dance. That's going to be 2 terms times 9 terms. Clean it up. Go from there. Identify the function even or odd. Well, first of all, I said negative, so I'm assuming it might be odd. I know I need p of x. I know I need p of negative x. And I know I need minus p of negative x. So we're going to come in here and make this minus 9x to the 5th minus 21x to the 4th minus 10x cubed. That should be squared right there. So he stays plus 6x squared plus 3x minus 1. Negative p of x says change everybody's sign. 9x to the 5th plus 21x to the 4th minus 10x cubed minus 6x squared plus 3x plus 1. Since p of negative x does not equal negative p of x, then this must be neither. Now you can go back here and check it to see, and actually you see that P of negative x does not equal to P of x, therefore it's not what? It's not odd or not even. Therefore, my answer is neither. Now, look at this one. Prove that the equation 3x has no real root. How do we prove that it has no real root? I don't know. Let's think about this for a second. When it says that, we can just see what kind of roots it has. 3x to the 4th plus 5x squared plus 2 really should have been a function, which is okay. I'm going to use Descartes, which says I have plus, I have 0, minus, I have complex, I have total. Total is what? 4. I have no sign changes. Let's change the odd x's. Don't have any odd x's. Therefore, I have no sign changes. This got to be what? 4. You can't subtract anything from 0, so you must have what? 4 complexes. Right? Out of curiosity, let's bring this up to Desmos, and let's see what this function is going to look like. I've got Desmos on my other screen. I'll drag it over in just a second. Good learning moment. We're about to bring it up. I'm going to type in f of x equals 3x raised to the 4th plus 5x squared plus 2. Drag it over. Notice, there's your graph. Does it cross the x-axis? No, no zero. So everything has to be what? Complex. Look how all that ties together. Pretty cool. If you understand the concepts, what they're asking for, it would save you so much time. Let's graph this guy. You know I'm huge whenever we graph. I'm always trying to do what? Y-intercept first. If you put a 0 right here, you get e to the 0. So f of 0 becomes minus 2/3 e to the 0 plus 3, which is minus 2/3, because that's 1, plus 3. So 3 minus 2/3 is 2 1/3. So that's about right there. Right? If you notice, this is a plus 3. So that means my asymptote is now going to be at what? Plus 3. Right? There it is. You should also realize that it's going to be a flip. So therefore, he's going to hug real close here and then drop down. There it is. Don't forget this stuff we already know. You're making me nervous. A lot of people freaked out over word problems. Why? No big deal. This guy's telling you t equals 0. So what are you going to stick right there? A 0. Then that simply becomes p of 0, because at the year 2000, that's when your time starts. The time is 0. 5.4 over 6.1 plus 2.9 to the 1 times 1, because e to the 0 is 1. So that becomes 5.4 over 9, right? Ooh, that turned out to be pretty. That turned out to be 0.6. Cool. Billions, right? Now, if you go back, notice what this says. Predict 2,200. How many years pass by? 200. So now you're going to go back in here and go P of 200 equals 5.4, 6.1 plus 2.9, e to the what? Minus 0.02 times 200, which becomes 5.4 over 6.1 plus 2.9, e 0.2 times that is 400. Move the decimal back twice, so that should be 4, e to the negative 4. Plug it in, see what you get. I can't remember that answer. I can give it to you later. Oh, my favorite part. People freaked out on the logs. I don't know. So all you gotta do is watch this. Let me find it. I'm going to go up here. Here we go. Notice, don't forget the ain't B rule. Log base exponent, that's your answer, equals exponent. So you go base exponent equals answer. So when you do this, my base is 4, my exponent is 3, my answer is x. 4 times 4 times 4 is 64. Done. This base is x, exponent is 2 to the 3, answer equals what? 8. What kind of house is this? You could raise this to the 3 over 2 and kill it, but I'm going to simply say I know it's a what? Cube root house squared equals what? 8. We're going to raise this to the what power first? 3. To get rid of the cube house, I have x squared equals 8 to the 3. Now I'm going to take the square root. Take the square root, take the square root. I now have x to the square root of 8 times 8 times 8. X equals the square root of bam bam, right? So that gives me 8. 2 times 2 times 2, kill, kill. That takes that 2 out. Now I should have x is equal to 16 square root of 2. A natural log, what kills a natural log? 2 ways you can do this problem. Give him an e, give him an e, x plus 1 equals 1. X equals 1 minus 1, so x equals 0. That's one way. Or you can come over here, remember a natural log is just log base e, x plus 1 equals 0. What's my base? E to the 0 equals x plus 1. Whoa. What is e to the 0? 1. So we write back to the same problem. This becomes base is 7, exponent is x, 1 over 49. You know 49 is squared. Since it's on the bottom, it becomes what? Negative 2. Kill the 7's, x equals what? Minus 2. This is huge. You can't have two LNs. So once you know that an LN plus an LN means the two pieces are simply what? Multiplied. And that squared got to come up here, right? Let's bank that up. That has to be ln x squared. He has an ln, he has an ln. I can kill the ln's. Multiply by 2. I have 2x minus 1 equals x squared. That bad boy is quadratic, so he becomes x squared minus 2x plus 1. That becomes a zoom, 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 zoom. X minus 1, x minus 1. By this point in the game, I hope you know how to factor. That's why I left the factoring simple. I'm testing to see, do I understand the log properties? So x equals what here? 1. Make sure you test it. 1 minus 1/2 is positive. I can't take a natural log of a positive. I see 125. I see 5 cubed to the x, 5 cubed to the x power plus 5 cubed x plus 1 equals 100. Notice that's 5 cubed x 100, right? 5 cubed is 125. 5 times 5 is 25 times 5 is 125 cubed. Now I get to write this as 5 cubed x plus 5 cubed x times 5 to the 1 equals 100, because that plus 1 means I got a 5 to the 3x times 5 to the 1, right? Base times base as exponents. Now I have 1 5 cubed x plus 5, let's go 5 cubed x plus 5 cubed x's equals 100. So I have how many of those things? 6 of them, because 1 of them plus 5 of them is 6 of them. We're going to divide by 6. That gives me 5 cubed x equals 100 divided by 6, which is 50 over 3. Take the ln, take the ln. I now have 3x equals ln 50 over 3, because I'm going to divide by the ln 5 right here. Now we're going to take the whole thing and divide by what? 3. Cool. That's F. Let's see if I can squeeze some room in here for this guy right here. I'm going to bring him right here. You know you're going to multiply both sides by 1 plus e to the x. So that gives me 10 equals 2 times 1 plus e to the minus x. You know I'm going to multiply this by 10 equals 2 plus 2 e to the minus x. Actually, I can divide by 2 right here. Get 5 equals 1 plus e to the minus x, which gives me 4, because 5 minus 1 is 4, e to the minus x. I know 4 equals 1 over e to the x. Multiply both sides by e to the x and divide, or flip both sides. 1/4. Take the ln, take the ln, kill the e. So that answer right there should be ln of 1 over 4. That's x. That's for number G. Right? A little messy, but if you listen to it, you can follow it. That whole thing right there is grouped. Now, number I, e to the 2x is the same thing as e to the x squared plus 5e to the x minus 24 equals 0. I'm going to let u be e to the x I know I can factor that. I said negative 0 minus 0 plus, I see a 8 and a 3, 0, so my u equals 3, my u equals minus 8, my u go back to what? E to the x equals 3, e to the x equals minus 8. When you take an ln of both sides, when I take an ln of both sides, take an ln here, let's don't do that, it's messy. Let's come down here to put the ln right here, ln of e to the x to kill the e, ln e to the x equals ln of negative 8. You can't take an ln of a negative 8 of a negative number right here, so that's going to go to trash, the one on the right hand side right there. So now we're left with x equals ln 3. Cool. Expansion means take it and break it apart. I know right here I have 1 log, so that's going to be log, that is a x squared plus y squared raised to the 1/4. I know that 1/4 got to go in front. Where's the log? And that's all I can do. It doesn't say when you add logs you multiply them. It says it doesn't say the log of addition is split it up. No, it says when you have 2 logs you add them together, then you multiply them. Like this guy here, log x to the what? X squared y squared to the what? 1/5. The 1/5 goes in front, then that becomes the log 1/5 2 log x plus 2 log y. Because what happened here? That is x squared, y squared, right? The log is what? You add them, and then you throw their exponents in the front. You're combining logs. Now, this says you have ln 2 ln x. Let's fix those exponents first. ln 2 cubed plus ln x squared minus ln x plus 4 to the 1/2, which means that becomes ln 2 cubed is 8 times x squared, because they're adding, divide by the square root of x plus 4, right? You can leave it like that, or you can rationalize the bottom and the top. That becomes what? Bring up, take out, 8x squared, square root of x plus 4 over x plus 4. Doesn't matter to me. ln, adding logs, what do you do to the pieces? You multiply them. We're subtracting a log, what do you do with the pieces? You divide by, the square comes up here. You know the difference of two squares is when you break it like this. So that should be, and if you FOIL it, you should get a squared minus b squared over what? C squared. Done. That's a little nasty, sorry. Right? Radioactive radium, like this one. Half-life. Half-life says what? Whatever I start with, I can start with rho naught. I'm going to have what? Half a rho naught. But what I like to do to keep everything pretty and simple, if I start with, actually doesn't matter. I start off with, I'm going to have half rho naught is my final. If I start off with rho naught e to the kt. It is a decay function, so let's call this a minus kt. My r naught's going to cancel. I'm going to take the ln of 1/2 minus ln equals ln e to the minus kt. What does the ln do to that e? Kill each other. This becomes ln of 1 minus ln of 2. That becomes minus kt. This becomes, go to 0, minus ln of 2. That becomes minus k, and my time was 30. So my k turned out to be negative 2. Sorry. My k turned out to be minus ln 2 over 30. Let's break out the handy dandy calculator. I don't know. I'm just going to hit the button. Boom. There it is. It's going to pop up. There he is. I know. ln, sorry, K, 2 ln divided by what? 30.0231. So that divided by 30, bam bam, my k turns out to be negative 0.231. Next part says, how much should you have after 15 seconds? Whoa, back up. How long would it take for 85% of the sample to decay? Well, now you're going to go back and do what? Find time. So now you have your function. Now you have your function. I'm going to do all that writing over here. Now I have my function. It says r of t equals, I want 85% to disappear, so I have 0.5 left. Start off with 0.80, start off with r naught. So I got 0.15 r naught equals r naught e to the minus 0.231 t. Solve for time. R naughts cancel, right? You have 0.15 left because you want to have 85% if they disappear, so 0.5 is going to be left. Take the natural log of both sides. I'm left with minus 0.231 t divided by minus 0.231 minus 0.231, bam bam. T turns out to be, can't remember, but it should be kind of small or kind of big. Let's see. 0.15 ln, sorry, 0.15 ln, right? That's negative divided by 0.231, which is negative. So that should give me minus 8.21 seconds. Is that right? Well, if it took 30 seconds for half of it to be gone, my answer should be more than 30, right? Let's try that again. My handy dandy calculator says I have, that was 0.15, my R, I'm going to have 0.15 left, my constant was 0.231, so I should be able to take 0.15 ln and divide it by 0.231. I get 8.2 seconds. Don't like that answer. Okay, found the error. Somebody just let us go drive off the cliff. So let's figure out where it's at. Here it is. This should have been 30, right? 30. So that's going to become k equals minus 0.0231. Make this right here minus 0.0231. 0231. So now that becomes something like 81 seconds. Like that. That's the dogs. Okay, we got that answer. Let's go back up to number 21D, 500 grams. How much would you have at the 15 minutes? The trick there was, once again, you got your equation. Once you have your equation, you're cooking with grease. So we're going to come up here. Let's catch it on the side right here. That gives me, what does that give me? It gives me RT equals, how much we starting with? 500. How much time we have? 15 minutes. But you got to remember, I'm trying to get you. Minus 0.0231. 15 minutes is how many seconds? 15 times 60 is 900 seconds. So that's just a straight plug-in calculator problem. And I think that turned out to be very, very small. Let's see what we get. I'm bringing out the handy dandy. I'm going to go, where's my E button? That's my exponential right there. So what we're going to do is we're going to take 0.0231 times 900, right, equals, change the sign, exponent that, should be my exponent button. Hang on. Okay. Want to be difficult. Okay, we're going to bring out the big boy. This one says we had a 500, right? 500, right? Exponential key is somewhere. There it is. Second. Actually, I'm going to clear this up a little bit. Let's say clear, start over. 500. Second exponential. I have negative 0.0231 times 900. So that should tell me I should have a very small number, 4.67 times 10 to the minus 7, which if you round it to 0, pretty much almost nothing's left. Okay, so that gave me a answer of I think it was 8.77 times 10 to the minus 7, which is very small. Makes sense. Now, remember, we talked about this. The X tells you where it's at. The Y tells you what it is. Find absolute minimum values. We know we have one absolute minimum. What is the value? The value is minus 6. Find the absolute maximum value. The maximum value is 8. Find the local minimum values. Everybody's local, that's low. So I have a minus 6. I have a minus 2. I have a 4. And I have a 1. All of these guys right here are my local minimums, right? The next question is find the local maximum values. So I have actually this guy right here, 6 minus 2 should be, find local minimum should be minus 6, minus 2, and minus 2. This guy right here is a max. 22D, find the local maximums. I see a minus 2, I see a 4, I see an 8, and I see a 1. Right here, 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 and here. Where is the absolute minimum? Well, the absolute minimum occurs at x equals minus 9. Find f of 4. That says my x is 4. What is my y? It is negative 1. Right? Get rid of that. Minus 1. Find f of 6. When x is 6, y is 1. It says find f of x equals 0. So that says, hey, what are my zeros? Where does it cross the next axis at? I see it cross the x-axis at negative 5 approximately, negative 1 approximately, 0 approximately, about 2.8 approximately, and about 5. Don't forget, x tells you what? The abscissa tells you where it's at, and the ordinate tells you what's the value. This was trash, extra page, and the last page. I think that was it. Cool. And that's the test. I'm gonna go make some trig stuff now. That should flow pretty smooth.